Well, I've not started this radio yet, and I already don't like it. This is the Albrecht AE6690, which is quite an expensive radio with built-in CTCSS. And I think these have been around since 2014. I think we bought this one about 4 years ago. And I was talking about the time when I sent Mark ZX2 with a dozen different radios, and I didn't know which one he was going to pick next, and one of the sets was this. Well, it didn't work at 35 miles, and all the other ones did. So, apart from the early version of the something 3000, it'll come to me. Well, I've recently been able to download this from CB Radio Netherlands. So all credit to them. This is 2/3 of a service manual. All the instructions to do the alignment aren't there. And I've also included, for my own benefit, the page 17 from the instruction book which comes with this radio. So we do have a block diagram. We do know what it's supposed to do. And I'm just going to pause this while I work out what that is in English. Well, it's not. This is a translation, and here in England, we do things either in dBm or microvolts. So let's have a dB microvolts. What would we have here? Yeah, just over 1 microvolt, which isn't brilliant if that's true anyway. So we know about printed circuits, we know about layouts which don't tell us much, apart from links we're not interested in, and we know what parts are in it, so that's reasonably handy. And we've got that circuit diagram, and we've got 2 layouts, and we've got another printed circuit board, and a bit of something, and a bit of something else, and a few more parts listed, and another bit of a circuit diagram, and another bit of a layout with the front panel. So I can't say I've worked that much out from that. We know where the Squelch control is. Start again. We know where the deviation control is. When I bought this in for a demonstration for a customer who wasn't impressed, I did adjust the deviation. So we're going to hope we can make this a bit more sensitive. I don't know whether these radios are a load of rubbish or whether it's just out of alignment and it's come to us like that. So it's been sat on the shelf for 3 years plus. Mark didn't get on with it, I didn't get on with it. Let's open it up. Well, at least the loudspeaker is on a plug, so that has given it some redemption. Now these are still current, but go back to 2014, and I know they go back to 2014 because it says so on the circuit diagram. So I say I've got the circuit. It isn't clear at all, and most of the coils aren't numbered, so they're not on this circuit. So yeah, we did work out that T5 looked like it's the detector. That's clearly the modulation transformer for AM, and that's clearly the choke for power input. This is clearly the filtering for the transmitter. That'll be the transmitter output device. That'll be the transmitter driver, and one would expect the coils down there to be transmit and the rest of them to be receive. Some IF ones, so the detector, and there'll be, perhaps that's the VCO just there. I don't know whether it's on frequency adjust. Oh, it's that one there. It's going to be that one there, which is not numbered, but is is going to be it, I am sure. So what we'll do is just get it connected up to power, and it wasn't transmit that the moan was, it was abysmal receive. So it's lit up and it says it's UK channels, channel 20, tone squelch off. Now this has CTCSS. If you want me to discuss CTCSS, we can always do something on that, but effectively it masks other users on the channel you're using. So they're still there. It doesn't make you better range, but you don't have to listen to all the racket. And especially if you're driving through a town and you've got people with interference coming out of their houses and you're constantly having to mess with the squelch, it would mask that, but it doesn't improve your range, and probably could say we could drop the range. It's basically it's looking for a musical note which is subaudible. The list starts at 67 Hertz and it goes up to 250.3 Hertz, and the idea is that the radio transmits this musical note which is supposed to be subaudible, and the receiving end filters it out and acts upon it. If it sees that musical note, then there's effectively a handshake and it puts the message through, and if it doesn't see the musical note, then it just keeps the speaker closed. So business systems have used it for donkey's years. Motorola, of course, call it by something different. They call it private line. Yeah, right, very private. So I'll tell you what, we'll just get this frequency out of our system and get that on frequency. We will just switch to the other camera. So we're going to transmit. It should be 2779125. It's 2779128. That is excellent. And I understand it is. I'm going to have to put my head in this and just find out what pause it. Yeah, I couldn't see it from this angle. When I put my head in it, I can see where the crystal is, and right next to it we've got the trimmer capacitor. Now we've got this new camera on this new bracket, and it'll still be abysmal when we zoom in, but so we're talking about the preset just there, the variable capacitor. So just to show you it move, even though it's spot on this sample, key up 71928. I can turn it that way and that way. Probably never get it back quite as well as it was. There you look at that, 2779127, that'll do nicely. So that's the first one, frequency set. So I'll switch to the other camera and then you can see the power meter on the radio. Okay, so I managed to work out from the various layouts and the circuits and what is there in my copy of the manual what's what, and I've worked out from the circuits that receive coils are transformer 1, 2, 3 and 4, so that's 1, 2, 3 and 4 done in green. Transmit ones are 9, 10, 11 and tank coil 1, 9, 10, 11 tank coil 1. We've already covered the frequency, and VR1 looks to be S meter and VR3 is deviation. So that only leaves us with VR2. There isn't a 4 and 5, but there is a 6, which is power adjustment. So that's what we will play at right now. So I'm on the 30 watt range on my test set. So 5 watts is there, so 4 watts should be there. Let's key it up. Yes, it's just doing 3. So we'll turn it up with the power control first. Oh yes, it does. Yeah, it goes to 3.2. And then we will do transformer 9. Oh, that's the VCOs we're going to leave well alone. The instructions in the service manual for setting that up aren't present. So that is peak, it already was, no improvement. I'm doing this on channel 20 on UK channels. If you wanted this to work perfectly on the CPT channels and UK channels, you would do it on channel 1 of UK channels or channel 40 of the CPT channels. But we don't need it to work on CPT, although we might do a test one day on channel 40. So we're now moved over to TK1. And there we are with no improvement. So I'll just check this power control again. I'm not turning it to full because there's a point at which there's no improvement. It's drawing 1.5 amps at that point, and that is 3.1, 3.2. Alright, so I've gone backwards and forwards several times on that until I now have 3.3, something like that. Wow. Yes, I know there's some naughty link which turns it into a 9-watt radio, but it's already far too hot as a 4-watt radio. Yeah, we've had modified radios before which have blown parts. Okay, let's have a look at deviation. Now that should be right because we set that up for our demonstration 3 years ago. Wallow. Wallow. Yeah, spot on. See what it listens, what it sounds like. Testing 1 2, testing 1 2. Yeah, that's fine. Now we'll just prove that the deviation control VR3 is what we think. That we know that VR3 is deviation, so we should be able to key this up and adjust it. And we can. So let's put it about 2. Wallow, it's just a fraction over the top. Wallow, that's spot on. But as I said, I adjusted that. That's the only thing we had adjusted before. So that is VR2, and it's exactly what it does say in the manual, which is just there. So we've covered power, we've covered deviation. What's that? It could be AM modulation, it could be squelch, I really don't know. Oh yes, I do. It says meter, it says so. So which one don't we know? Oh, it's VR2 we don't know, down there. Right. So what does the RF meter? Well, I can assure you from the circuit diagram that there isn't an RF meter which is adjustable, in line with a lot of modern sets. You key it up and it gives you a full set of bars. Out of interest, we'll fiddle with VR2, but I doubt that it's going to do that. I think it's going to be AM modulation. And to try and show it to the camera. No. So what I'm going to do, I'm going to program it for an AM set of channels. So if we look at the lid, wherever I put it, it says how to do that. So we'll go for the E set of channels, because in the UK we're now entitled to 4 watts of AM. Yes, there is a link inside which will always make it AM 40, AM 4 watts, but we don't do modifications here. So switch it off. Press FC and BP and switch on. So FC, BP, switch on. That didn't work, did it? Press FC and BP and switch on. Perhaps you have to hold it in longer. That's it. E. That's what we want. And then it says SC to confirm. There we go. So put that on channel 20, and hopefully we are in AM mode. It says that. So I'll have to reset our modulation meter. Barlow. And let's just see, bring the little oscillator back, and we'll see whether the mystery control is modulation. Oh yes. Perfect. It's about 85%, 90. Right. So why didn't it say so on the circuit? You know, is it all cloak and dagger? So AM mod. I'll colour that in red later. AM mod. Good. I'll get this back onto UK, and we'll do the receiver. Right, I've switched the bench lights off so we can see the oscilloscope screen a bit easier. And according to the service manual, I have worked out that the detector is 5 is the detector. So I'll just write those in because I've missed that. There we go. So T5 is the detector, and that was T6, which I thought was. I'm glad I checked. So we're on channel 20 UK. Put it back on UK FM, and put the signal generator on. So with an S9 signal, let's put a bit more volume on so we can see that easier on the oscilloscope screen. Let's change the gain as well. So we're now on 0.1 volts of division. Yeah, then you see that wasn't peaked, and that could make all the difference on FM. That can really affect the range. So even if you've got the sensitivity, if the detector's out, and it was, then that can really affect it. So now as I turn the attenuator down, oh, it just sounds lousy, doesn't it? Oh my goodness. You go under, that's 3 microvolts. Yeah, something's out of alignment, isn't it? Right, we'll move the camera over to the cyanide meter. Okay, so we'll try and drop that so that we've got about 4 decibels on the cyanide meter. If I can actually hear it. And drop the squelch. Oh, was that the squelch coming in, sounding like that? Yeah, that's what the squelch was causing. Okay, transformer 1. Wow. Transformer 2. Transformer 3. Transformer 4. I'll just drop that a bit again. So I'll just do those again. We've gained more. Because they are interactive to some extent. Very good. That one at the front could be an AM detector, so I'm just going to have to go back onto CPT AM and just prove that. Okay, so we're now on channel 20 CPT, that's 27.205, and we'll see whether that's an AM adjustment. Well, being able to peak it easily, whereas I wasn't able to on FM. I'll just put a high signal on, and just to do another type of check. So this time I'm looking at the oscilloscope screen, just see whether... No, that was the best way to do it, with a really low signal. There we are, that's definitely peaked, you can hear the difference. Audio millivolt meter would actually be the best instrument to use, and we have one, but it goes without saying that that is on the other bench. So that is set up. I've used the oscilloscope, I've used the cyanide meter, so I'm happy that's the receiver set up, and there's a huge improvement, and you saw that happening. What I'm now going to do is we'll try and get that S meter set, and I'll tell you what, we'll do it on AM. I'm still on AM. Now, if you remember, I upset it by adjusting VR1. I adjusted VR1. Oh, there we go. Oh, it's not calibrated. It's just a bar graph that goes up. It doesn't say S anything. So I've got it 2 bars from being at the top. Oh, that's okay. We'll just put it back to UK FM and see whether it still reads the same. So there we are, back to UK FM. Let's pop some volume on it. And as you can see, the S meter is still where we left it. We can make that go higher, and we can make that go lower. Let's just see whether what we can still make that go higher. Yeah, we can. That's probably a better setting. It's not calibrated, you know, it's just Had it been a bunch of LEDs, we'd have just said it's fairy lights, wouldn't we? So it does do something. The RF meter does absolutely nothing. It just I tell you what, we'll do an experiment. We'll turn the power right down. Just turn the volume down. I'll turn the volume right down, and I'll turn the power down on the radio. So I'm going to go into transmit, and we're currently doing 3.5 watts now. It's cooled down, so I'm just going to turn that down to 1.5 watts, and we've got that number of bars, and we'll turn it up to full 3.5 watts. And that makes absolutely no difference whatsoever. So it's just a glorified TX light. So we're back to the full 3.5 watts, which this radio is doing from cold, or 3.2 watts when it's got pretty warm. So that covers it. I don't think we've left any stone unturned. The thing has Roger Bleep. As I say, it's got the tone squelch, which is also known as CTCSS, on-off volume, squelch, timeout, timer, all kinds of things. There's all that in the instruction book, which is readily downloadable. So we're now getting what? Because it was abysmal, wasn't it? That's now 0.3 of a microvolt, 0.2, 0.15. At 0.12. So it's still not the most sensitive radio in the world, but it now is better than a Uniden 200. So we will see. I'll just check the squelch and then we'll call it a day. So we'll turn the signal generator off. Not that the squelch is adjustable, as in internally adjustable. So that's set threshold. We'll turn the signal generator up and on. That's coming straight away, that's fine. Turn the squelch to full. Unfortunately, has this got auto squelch? No, it wasn't on. That's pretty weak, that. Let's see how the auto squelch works. So I've now switched to auto squelch. So we've got the signal generator off. Switch the signal generator on. And it's come straight in. So if you want a strong squelch, this is not the radio to have. Because this is equivalent of about an S3 signal that it's still putting through even on manual squelch. Signal generator off, signal generator, it had to be 1 microvolt, that's the best that we can get. But it isn't internally adjustable. Perhaps there's some menu which sets up the auto squelch, I don't know. But we've done the internal controls and that's what we're here to do. And it's been a vast improvement than how it was sent to me 3 years ago, and we've hated it ever since. So I'll get a on the air test done with Mr Chippie, and hopefully we'll do the full course and it not drop out at Scratchy Corner, as I think when we tried this before we couldn't get beyond the Kelby turn, so we got about 3.5 miles out of it. So we'll just pop it on an aerial and we'll just see whether there's anybody out there. So we can set it on scan. Probably. Oh. Hopefully you can adjust these. I wouldn't vouch for that because I haven't read the manual. We'll take it out of scan. 19er, Roger. And if you didn't know, it's got a super lightweight electret mic with up down, and it glows in the dark. Wonderful. Imagine a lorry driver holding that, can't you, and crushing it in one go. So there you have it, a now improved Albrecht AE6690, and we'll do an on-the-air test, and I'm sure that it will do the kind of sensitivity that we've come to expect on the UK set of channels. Very disappointing that it's come to me in such an out of tune state, and that was bought brand new. So thank you for watching the Albrecht AE6690.